Yes, chapter 1, section 1 is about defining the rotational motion and circular motion. And first, I will remind you what rotational motion is. Remember last year in the 11th grade, you studied that if an object is moving on a line or on a path, so these types of motion the object followed is known as translational motion. But now the object will rotate in place. We are not going to move it, so just rotating, spinning about a point. So in the chapter 1, section 1, we are going to study about this motion. When an object spins or rotates about an axis, we said that it undergoes rotational motion. This is the definition of rotational motion. So then an object will spin or rotate. So then this type of motion is known as rotational motion. Every single point on a rotating object moves around a specific point or line. So when I was rotating this pen, so then right now, this pen is rotating about or spinning about a specific point, this point. So this point about which all the points of this object is rotating is known as the axis of rotation. For example, here is a Ferris wheel. So, Ferris wheel is spinning about a specific point. This point is that specific point. So, it is the axis of rotation. So, axis of rotation is defined in the book by two ways. One of them is, or two definitions. First one is the line about which the rotation occurs is called axis of rotation. So, then when an object is rotating about a point, because object is a rigid object, very thick object, huge object, so all these points are forming a line. That's why we say axis of rotation. Axis means the line. So about this line, this object is rotating. This is the first definition and very important definition. The line, like this one, another definition of, or another axis of rotation for Ferris wheel. The line about which rotation occurs is called axis of rotation. And a specific definition of axis of rotation for Ferris wheel is like this. It is a line perpendicular to the side of a Ferris wheel. So now this is the side of a Ferris wheel. And this line must be perpendicular to this side. So it is a line perpendicular to the side of the Ferris wheel, passing through the wheel's center. You see this is the center of the wheel. So this line is passing through this wheel center and perpendicular to the side of the Ferris wheel. So then this is the definition of axis of rotation specific to Ferris wheel. This is the definition of axis of rotation according to all types of spinning or rotating object. So every point A or B like this rotating on a rotating object travels in a circle. So now this is a rigid object. Rigid means its shape is constant as it is moving. Yes, this shape is not changing. So rigid means its shape does not change when it is moving or rotating. So then every point travels on a circle like this. Here is a point A, here is a point B. Sometime later this point A will come here, B will come here. As object is spinning, these points will follow a circular path. Not only this point, every point on a rotating object travels in a circle. So then the motion of these types of motion and the motion of these single points on this rotating object is known as circular motion because they follow circular path. So two words are generally referring to circular motion. One of them is revolve, the other one is orbit, or sometimes travel, sometimes only move. So these words, when you read these words, you will understand that word is talking about referring to circular motion. Okay, and now as a Ferris wheel is rotating, the Ferris wheel spins, which is rotational motion, but the cabins, those cabins are following circular path. That's why the cabins or light bulbs, there are light bulbs, all those light bulbs follow circular path. That's why we said that the Ferris wheel is spins, which refers to rotational motion, but the cabins or lights follow circles. That's why bulbs or cabins are in circular motion. So, regardless the shape of an object, any single point on an object travels in circle around the axis of rotation. Look at this one. This is a calculator. So if I rotate this calculator about this point, for example, this button, which is ank, this ank will follow circular path about this one. So it will follow a circle. Or this del button will follow a circular path when it is when this calculator is in rotational motion. Okay, so that's why we don't care about the shape of the object. Any object, regardless the shape of the object, that's what it says, any single point on an object travels in a circle around the axis of rotation. So then, if every point on a rotating object follows a circle, so then first we should learn what a circle is, property of the circle. Now we will define a circle. In fact, this is a little maths, but this is very important for 12th grade physics. So what is a circle? In a circle, all the points are at a certain distance from a fixed point. So this is a fixed point, which is known as center of the circle. Every point on a circle is at equal distance from the certain distance from the fixed point. That certain distance is known as radius of the circle. And all of these points forms circumference of the circle. So this is called, this line is called, or circular line is called circumference of the circle. So this is the fixed point, which is the center of the circle. And every point on a circle is at a certain distance from the fixed point, which is from the center. That certain distance is known radius of the circle. The distance from the center to a point on a circle is called radius. Yeah, this is the radius, this is radius, this is radius, that is radius. Every line from center to a point on the circumference is named as the radius and represented by r. But the length of the line passing through the center and touching 2 points on the circle is called diameter. Look, okay, then this green line is passing through the center and touches 2 points on the circle. So this is the diameter. Diameter is twice of the radius. This is one radius. This is another radius. That's why we will multiply diameter reduced by 2 to get the diameter. Or to get the radius, we are going to divide diameter by 2. But as I said, this linear circular line is known as circumference. This circumference also has a length. The distance around the circle, this distance or length of the circle is called circumference c and calculated by 2 pi r. 2 pi r. Pi is 3.14. R is the radius of the circle, and by this equation we can find what is the length of this circle, which is known as circumference, or length of the circumference. And circular motion is more accurately described in terms of angle. So why is it like this? Now I will give an example. Travel distance alone, just the travel distance alone cannot properly describe circular motion of the object. You know, travel distance from the 11th grade is a translational quantity. It can be linear or non-linear. It can follow a path, or it can follow a line. It can follow a circle, but it's a translational quantity. But this distance traveled by an object alone cannot define the circular motion of an object alone, like this. Two bicycles, for example, if I say there are two different circles, One of them is big, the other one is small. If somebody says you, two bicycles A and B move equal distances, 100 meters in the following circles. So then what is the final position of these bicycles? Can you say that without knowing the information about how big this circle is or how small is that one? So if you don't know about this, so we cannot find what is the final position. We cannot find the exact position, final position of these two bicycles if we are not don't have enough information about how big is this or how small is this. Even though initial positions are known, final positions cannot be determined as certain because no information is provided about how big circles are. But if we say by an angle, if we say that two bicycles, A and B, move equal angles, for example, say 90 degrees in the following circles. 90 initial positions are these. 90 degree, yes, this is 90 degree. This is another 90 degree. So then I can say that where is the final position of the bicyclist on the big circle, on the final position of the cyclist on the small circle. I don't care how big or how small. That's why angle is sometimes more very useful to define the position of an object which is moving in a circle. That's why maybe you heard in some movies when in the sea or in the air, the airplanes are sometimes defining their position in terms of the angle. That's why this is used. Final position of the cyclist can be determined by an angle, even though no information is provided about the circles. We don't know how big is this, what is the radius of that, what is the radius of this, but we can find that after 90 degree of turn, this bicycle comes here, that bicycle comes there. That's why when we are studying the circular motion, we are going to use angle for defining the motion. And then we are going to define first full circle. If an object moves in a circle once, so then it's say that it starts from B, follows the circular path and again to the B. So it is the rotating or subpattern moving in one time. We say that the object makes one turn. This is called the one turn. One turn. It completes one revolution. It's about the circular motion, don't forget. Circular motion. One revolution. So then the bicyclist, it travels a distance which is equal to circumference. It travels a distance which is equal to circumference. A circumference is equal to what? 2 pi r, of course. So then this bicycle moves a distance of 2 pi r at one turn. Its angle of turn is 360, which is equal to 2 pi radian. So then from here to there, this angle of turn is equal to 360 degrees, which is equal to 2 pi radian. If bicycle turns not full circle, semicircle, say that from here to there. If an object moves in a semicircle, half a circle, semicircle means half a circle, once from here to there, it makes half a turn. It completes half a revolution. It travels half of the circumference, like what? Circumference is 2 pi r. Half of 2 pi r is what? S here is equal to pi times r. Its angle of turn is 180 degrees. Yes, from here to there, this angle is 180, which is equal to pi radian. Pi radian, 3.14. Pi is 3.14. Full circle, half circle, same circle. Sometimes a turn can be 2 turns, 3 turns, 4 turns. When it says turns, it's revolution. 1 turn, 2 turn, 1 and 2. 1, 2, and 3. So then turn. Sometimes students get confused. What does turn mean? It's the revolution. And what if the object is moving not full circle, not semicircle, a part of circle, if it moves, like this one. This bicycle starts from here and then moves there. It's just some angle. Angle of turn is theta. If an object moves along a part of the circle, part of the circle in maths called arc. So this is called an arc. So then it travels a distance s, which is equal to length of the arc. So s, length of the arc is s. It's a linear quantity, arc length. And its angle of turn is theta radian. So then it turns an angle which is equal to theta, which is the rotational quantity. This arc length of the arc, radius and this theta are related. S, R, theta are related by an equation. What? Theta is equal to S over R. If we divide two linear quantity, S over R, we got an angular quantity, theta. So, and this is the basic equation of rotational motion. Theta is equal to S over R. Length of the arc divided by radius is angle corresponding to this arc. So this angle is measured in radian, but not degree by the time. If we divide S by R, we will get the angle in radian. This is, as I said, the basic of all other equations which relates linear and rotational quantities. And then we said the radian. What is this radian? How can we define radian? Or how mathematicians define the radian? One radian is the angle whose arc length is equal to its radius. This is an angle which is 1 radian. Then this arc length and that radius must be equal to each other. What does it mean? If this arc length is 1 meter, radius must be 1 meter. If arc length is 10 centimeter, radius must be 10 centimeter. Then I can say that it is 1 radian. But 1 radian is equal to how much? 57.3 degrees. Yes, 1 radian is equal to 57.3. Which means if this angle is 57.3, arc length and radius are equal. And it's a pure number with no dimensions. Why? Because S is length, R is length. Length divided by length, they simplify. That's why just number. It's just a number. Radian has no dimension for that. As you remember, in the 10th grade, you learned that dimensions, length, mass, temperature, time, second. These all these are the dimensions. And then because both are length, S and R, length and length simplify. That's why radian has no dimensions. And how can we convert the radian to degree then? We will now learn about this. It's very easy. As I said, one revolution corresponds 360 degrees, which is equal to 2 pi radian. If you know one of them, then you can get the others. 180 degree must be equal to, if we divide 360 by 2, you got 180. Divide 2 pi by 2, which is pi. So which means pi radian is equal to 180 degree. 2 pi radian is equal to 360 degree. So then, if I use this equality, which is pi radian, and 3.14 radian is equal to 180 degree, any angle in radian can be converted to any angle in degree. So pi cross multiplication. That is so simple. Cross multiply them. So angle in degree multiplied by pi radian is equal to angle in radian multiplied by 180, like this. Let's apply one of them. Convert the following angles to radian, which is 35 degree. As I said, pi radian is equal to 180. So then angle in radian, we will convert this degree to the radian by 35 degree. We will convert the radian, cross product it, and then find it. Angle in radian multiplied by 180 is equal to 314, which is pi multiplied by 35. And then go with the simplification. Divide by 180, as I did here, and 180, simplify them. So that when you do this calculation by your calculator, you will get the answer as 0.61 radian. So which means 35 degrees is equal to 0.61 radian. Or we can get an equation for converting radian to degree to radian. So as I said, angle in radian multiplied by 180. Angle in radian multiplied by 180 is equal to pi times angle in degree. So if you need to calculate what angle radian is, divide by 180. Divide by 180. Simplify this, so then it's going to be angle radian is equal to pi divided by 180. Pi divided by 180 multiplied by angle in degree. From degree to radian, this is the equation. But sometimes from radian to degree, you need to calculate. Just do this reverse. So angle in degree is equal to, reverse this. Invert, flip it. 180 divided by pi, angle in radian. So then you can get by this equation, you can convert radian to degree by this one, degree to radian by that one. There are some other conversions. One more method some students are using the definition of the radian. We know that 1 radian is equal to 47.3 degrees. So then how many degree is equal to how many radians? For example, let's use above question. So they say that 35 degree, you are going to convert 35 degree to the radian by this equation. 35, write it here, 35. Which means 1 times 35, as I did here, 1 times, theta in radian multiplied by 57.3 is equal to 1 multiplied by 35. 1 multiplied by 35. Divide by 57.3. Divide by 57.3. Simplify. So then 35 divided by 57.3, which is equal to 0.61 again. So it's up to you which method. In fact, converting radian to degree or degree to radian is a kind of cross multiplication. It's so simple. But sometimes some students like to use the equations. Some uses the definitions. Some uses simply cross product. It's up to you which one is best for you. Find it and do it. And ministry exam questions about the rotational quantities. Every 2 pi radian is equal to how much? 360, 180, 90 or 60. Of course it is 360 because 2 pi radian is 1 revolution. 1 revolution corresponds to 360 degrees. Okay. Every 1 radian is equal to, yes, this definition of the radian. 1 radian is equal to 57.3. Don't forget, this is a very important number. Which of the following equals to 2 pi radian? 2 pi radian, remember it was 1 revolution, 2 pi radian. Anything in degree, what is 2 pi? It's the reverse of that one. Similar, yeah, same. Every 2 pi radian is equal to what? Which of the following is equal to 2 pi radian? These two are equal, similar, I mean, almost equal questions. Of course, 360. And convert this one. 270 is equal to how many revolutions? Sometimes students are getting difficult for these types of questions. It's again cross multiplication, so simple. So you are going to get the relation between degree and revolution. We know that 1 revolution is equal to 360, corresponds to 360 degrees. So then how many revolutions is equal to 270 degrees? We'll get this. Cross product again, simply use cross product. X multiplied by 360 is equal to 270. X is equal to 270 divided by 360. So then simplify zeros. 27 divided by 36. Divide by 9, 3. Divide by 9, 4. 3 over 4 is the answer, which is A. 1 degree is approximately equal to how many radians? Of course, we know that 1 radian, sometimes it can be converted. 1 radian is 57.3, but 1 degree is how much? We will use that. Remember, theta in radian is equal to pi over 180 theta in degree. This was the equation. So you are going to write here 1 degree, only things, 1 degree. If you write it, theta in radian is equal to, if you write 1 times pi is 3.14 divided by 180 multiplied by 1, don't write 1. So then the answer is C. And 45 is equal to how many? Again, very similar to the fourth question. Again, use simple cross multiplication. What is that? 1 revolution is equal to 360 degrees. 45 degrees is equal to how many revolution? Cross product. So then x times 360 is equal to 1 revolution times 45 divided by 360 divided by 360. 45 divided by 360. 45 divided by 360, which is equal to 0.125 is the answer. 1 over 10 revolutions is equal to how many degrees? This is also the same as this one. So then we will say that 360 degrees is equal to 1 revolution. Yes, 1 revolution. So then 1 over 10 revolution is equal to how many degrees? So then, in very simple maths, 1 is 360, 1 over 10 divided by 10. 1 over 10, 360 divided by 10. Simplify, it's 36. 36 degrees. And 314 divided by 180 radian is equal to how many degrees? Again, radian to degree, we will convert it. Remember, we said that theta in degree is equal to pi 180 degree divided by pi radian multiplied by angle in radian. Theta in degree is equal to pi 180 divided by pi multiplied by how many radian? 314 divided by 180 is radian. So they all simplify. So answer is 1. It is the 1 degree. Answer is 1 degree.